So far, we've looked at analyzing general graphs. We've looked at analyzing graphs that are functions. Now we're really going to focus in on one particular function, and that is the quadratic function. So we'll be looking at quadratic functions and their properties. So if you'll remember from prior sections, the simplest quadratic function, the parent function, is y equals x squared. And there we have that function right there. Now there's two different ways that that function can be written when it's not just the parent function. The first way is, as you see, form 1, where we have f of x equals some number times x minus another number squared plus k, a third number. This is what we have been working with when we were working with transformations. So this is the form that actually shows us the transformations that have been made to that particular function. Now, in that case, we call where that parabola, which is a quadratic function, that is a parabola, we call where it sits, we call that its vertex. And when the function, the quadratic function, is written in this form, form 1, its vertex can be found at the point h, comma, k. Now, we'll explore that a little bit later. The second form of the function is basically the same as this one, but whatever is in parentheses here, squared, has been all foiled out, and then distribute the a to it and then combine like terms, and it looks like this, ax squared plus bx plus c. You've seen that in prior courses. But again, we're going to examine that when we are presented with an equation in that form. And when we are, the vertex then, where the function sits, is the point negative b, right there, negative b, over 2a, comma, f of negative b over 2a. And again, we'll look at that in detail a little bit later. So in general, we look at the a here or here, and if it is greater than 0, then the parabola opens up, meaning it opens like this. But if that a is less than 0, it's a negative number, the parabola opens down. So it would look like this. To find the x-intercepts, just like we always do, we let y equals 0, same as with a linear equation. To find the y-intercepts, you let x equals 0 and solve for y. The axis of symmetry, we talk about the axis of symmetry, all these things we talk about for Form 2. The axis of symmetry is a line x equals negative b over 2a. It's what goes right down the center of that parabola through the vertex. The vertex is either a max point, that's when the parabola opens down and a is less than 0, or it's a min point, that's when the parabola opens up or a is greater than 0. So these are some basic things you need to know. Now we're going to actually go into some problems and look at them. So let's first analyze quadratic functions that are given to us in Form 1. And we've already done a little bit of that when we did transformations. So looking at the next page, we're looking again at Form 1, which is the function is equal to some number times x minus h, quantity squared, plus k. So here's what I mean. F of x equals 1/4 x squared minus 2. And it says to graph it using the parent function and transformation. So this is a review from the last section that we did. So the parent function is f of x equals x squared, and we know that that looks like this. We know that. And right there is the vertex. So we have the point 0, 0, and we also have the point 1, 1, and negative 1, 1. So 1, 1, negative 1, 1. You could continue and find other points. We really don't need to do that, okay? Next, what we want to do is we want to do this vertical compression. 1/4. Remember, when it's a fraction, it's lazy. It opens up less. So what's going to happen is the x term, the x squared, is going to be multiplied by a 4th. So f of x equals 1/4 x squared is still going to give us the point 0, 0. So it's still going to be sitting here. It hasn't moved. But instead of going through the point 1, 1, what we're now going to do, and going through some of our other points, is we're going to multiply our x squared by 1/4. So let me just show you what I mean. So if x is 1, x squared is 1, excuse me, if, not x, that was y. If x is plus or minus 2, then that would give us 2 squared is 4 times 1/4 gives us y as a 1. So I have the points -2, 1 and +2, 1. And then if x is plus or minus 4, I'm picking things that I know will cross cancel with that 1/4. I square that, that would be 16 either way, and then 1/4 of that is 4. So I also have the point 1, 2, 3, 4, 1, 2, 3, 4. So you can see that it's much wider than my original function. That vertical compression opened it up and made it wider. Finally, we're going to do this, and we know that that takes it down 2. So the y is going to change. So instead of 0, 0, let me write the function first. F of x equals 1/4 x squared minus 2. So instead of the point 0, 0, it's going to be 0, -2, right? Instead of the point plus or minus 2, 1, it's going to take it down 2. Plus or minus 2, -1. And plus or minus 4, take it down to 2. So now it sits at 0, -2 right there. Plus or minus 2, 1, plus or minus 2, 1, plus or minus 4 is up here at 2. And it's still open. I didn't actually do that dot exactly right. It's still open and wide like it was here. I didn't draw it very well. My points are off. It's still very wide. Because of the 1/4 x, but it's now been brought down 2. And so you could see that the vertex here is at 0, 0. The vertex here is at 0, 0. But the vertex here is at 0, -2. And we'll talk about that a little bit later. All right, so now it says graph the function. We'll try another one. F of x equals x plus 2 squared plus 1 using the parent function. Maybe I can draw this one a little bit better. So f of x equals x squared. Again, we know we have the points 0, 0, plus or minus 1 and 1, plus or minus 2, plus or minus 2 and 4. So I've got 0, 0, 1, 1, -1, 1, 2, 4, -2, 4. So it looks like my parent function looks a little bit like that. Not too bad. Okay. The first thing we want to do is this inside horizontal shift. So f of x equals x plus 2 squared takes it to the left 2, which means my x is going to change. So I'm going to subtract a 2 from each of these x's. So I'm going to have -2, 0. From the point 1, I'm going to go over -1, 1. From the point -1, it's going to be -3, 1. From the point 2, I'm going to subtract 2, so it's going to be 0, 4. And from the point -2, I'm going to subtract 2, it's going to be -4, 4. So when I plot those points, I have -2, 0, -1, 1, -3, 1, -4, 2, and 0, excuse me, that should have been -4, -1, 2, 3, 4, 4, not 2. Sorry about that. So I didn't draw it better. 1, 2, 0 and 1, 2, 3, 4. So it looks like this. It's the same basic shape as this. That point is off. But it's moved over 2. It's moved to the left 2. So now the vertex was 0, 0. Now the vertex is at negative 2, 0. Okay? Now we're going to apply the last transformation, which is that positive 1. So f of x equals x plus 2 squared plus 1. Well, it's going to be this graph moved up 1. So it's going to have its center here, but up 1. And it's going to look like this, which gives us, I'm adding a 1 to each of my y's. So negative 2, 1. Negative 1, 2. Negative 3, 2. 0, 5, if you wanted to plot those points. Again, this is review. We've done this before. Let's look at analyzing a graph, however, a quadratic function, when it's in form 2. When it's f of x equals, all of this stuff has been FOILed out and distributed. So it's ax squared plus bx plus c. So here we have a quadratic function is given by f of x equals x squared plus 2x. So we want to know, and we're going to go back, by the way, I'm going to show you this again, to these characteristics of form 2, where if a is greater than 0, it opens up, etc., etc. So in this particular function, my a is a positive 1, so I know that it opens up. I find my vertex by first finding negative b over 2a. Well, let's name our a, b, and c, just like you do for the quadratic equation. So a is 1, b is 2, c is 0. So negative b over 2 times a is negative 2 over 2, or negative 1. That's the first part of my vertex. The second part of my vertex is f of that. So I have to go up here and say, well, what is f of negative 1? It's negative 1 squared plus 2 times negative 1, which is 1 minus 2, which is also negative 1. This is my vertex, negative 1 and then negative 1. So it's sitting right there. Now, I can't tell how to graph it the way I could up here by using transformations. So in that way, form 1 is kind of more informative and it leads you to the graph quicker. But I can use these other characteristics of my graph to finish graphing, because I can't just draw it. I want to be real accurate now instead of us just sketching like we've done in the past. So let's talk about the axis of symmetry. That's the line that goes straight down through my graph. Well, I can see what that is. It's going to go straight down through there. It's always going to be that, but written as an x equal equation. So once you have the vertex, you have the axis of symmetry. X equals negative 1. All right, the y-intercept means let x equals 0 in the original equation. So that would be f of 0 equals 0 squared plus 2 times 0, or that is just 0. So that tells me that it goes through the point 0, 0. So I'm getting somewhere. Okay, I also know it must go through this point because this is the symmetry line. So it's got to be equidistant on both sides of it. So I kind of know it's going like this, don't I? Let's find, though, the X-intercepts. Well, I already know one of them, 0, 0, correct? We just found it because it's the same as the Y-intercept. For the X-intercepts, we let y equals 0, which means I take my equation, x squared plus 2x, and I set it equal to 0. Factor out an x, use the 0 factor property, and solve. And I end up with the point 0, 0, x is 0, y is 0, and the point x is negative 2, 0, which I already knew that because I used my line of symmetry to find it. So that worked out pretty easily there. Now let's use a couple different colors. We want to know where is this, what is the interval where my graph is increasing? Well, it starts increasing here and it's increasing up that way. So what is x when it starts increasing? It's -1. And how far does the x go? Well, as it goes up, it goes right. It goes to infinity. Remember, that is an x interval. That is not a point. That is an interval. Where is it decreasing? Well, it starts decreasing and then it stops decreasing there. So it starts decreasing when x is -infinity. It stops decreasing when x is -1. Again, those are x's. Those values are x values. Finally, what is the domain? The domain is what my graph is allowed to be. If I look at my function, I know what it is because there's no variable in the denominator and there's no radical, so there's no restriction. So it's -infinity to infinity. What is the range? There is a restriction. You notice my graph doesn't go below this point. It doesn't go below where y is equal to -1. So it includes -1 and it goes up to infinity. So that's the lowest the y goes, and then it goes up. So that's analyzing a graph when it's in form 2. Let's do another one like that, a little bit harder one. A quadratic function is given by this. F of x equals -3x squared plus 6x plus 1. I'm immediately going to list my a, b, and c because it is not in transformation form. So my a is -3, my b is +6, my c is +1. So my a is negative, so I know that it opens down because it's a -3. The vertex, I'm first going to find -b over 2a. -6 over 2 times a is -3 is -6 over 6, which, -6 over -6, which is a +1. Now I need to find the other piece, which is f of 1. -3, take out the x, put in the 1, plus 6, take out the x, put in the 1. That gives me -3 plus 6 plus 1, or 4. So my vertex point is the point 1, 4. And somehow our graph seems to be missing from this page. And actually, I guess we don't need to graph this one. You're going to see why in just a minute. You'll understand why. But I do know that it opens like this, and I know this, that its vertex is at the point here. So I know it's doing something like that. Okay. All right. So does it have a max or min point? Yes, it does. It has a max point. And where is it? It's right at the vertex. So it's at the point 1, 4. That's where my max point is. What is the axis of symmetry? Well, I've told you before, the axis of symmetry, once you have your vertex, it's just x equals whatever your x value is. So it's that line that goes down through x equals 1 and goes through that vertex. Okay? The y-intercept, we let x equal 0. So f of 0 equals -3, 0 squared, plus 6 times 0, plus 1, which is 1. So I have the point x is 0, y is 1. So x is 0, y is 1. So I actually sketched that pretty close. The x-intercept is difficult in this one, which is why we're not actually graphing it. So the x-intercept means let y equal 0, which means I set the whole thing equal to 0. So -3x squared plus 6x plus 1 equals 0. I'm going to try to factor it first. Are there factors of -3 that combine to make +6? There are not. So I have to use the quadratic formula. So to find my x, x equals the opposite of b, so -6, plus or minus the square root of b squared minus 4ac all over 2a, or x equals, if you simplify that, you get -6 plus or minus square root of 48 all over -6. Don't cross cancel that because there's something in here. What you need to do is, rather than simplify that, just put it in the calculator. you're going to put negative 6, here, let me show you. You're going to put negative 6 plus radical 48 over negative 6, and then you're going to put negative 6 minus radical 48 all over negative 6. And when you do, you're going to end up getting 2.155 approximately, and you're going to be getting negative 0.155. Now you know why we're not graphing it. So my x-intercepts are the points. X is 2.155, y is 0, and x is negative 0.155, y is 0. So again, it's right there, and we're not going to worry about it because I can't graph that in such a small space. Let's talk about domain. Is there a restriction on that function? No. So it's negative infinity to infinity. But the range is not negative infinity to infinity because the highest it can go is right there. Y can be 4, but on the other end is negative infinity. So we want to write it like this. Negative infinity up to 4, including 4, and that's our range. So the lowest it goes is negative infinity, and the highest it goes is 4. And notice, I started to write the 4 first, but when I saw that it was opening down, I knew that the negative infinity had to come first. Where is it increasing? It's increasing with the x's from there to there. So it's increasing from negative infinity up to x equals 1. Remember, that's an interval. And then it begins to decrease. And it's decreasing on the interval beginning with x equals negative 1 and going to x is infinity because it's going to the right as it's going down. So there's a lot to analyzing these. You need to be very comfortable with that. So which of the following most closely resembles that graph? Well, obviously, look at what I've done. We should be able to figure that out. And right here, our vertex is a big help. I need the vertex at the point 1, 4. Well, this vertex is at the point negative 1 something. This vertex is the only one that is at the point 1, 4. So that is the graph. And I had already sketched it, so that was pretty simple. All right, let's look at number 5. We're going to do it one last time. So we have f of x equals x squared minus 6x plus 9, and we want to use graph analysis just like we did. So let's label, let me scoot it over. Let's label our a, b, and c. A is 1, b is negative 6, c is 9, a is positive, it's opening up. I want the vertex, negative b over 2a is the opposite of negative 6 over 2 times 1, or that is 3. And now I need f of 3. 3 squared minus 6 times 3 plus 9 is 9 minus 18 plus 9, which is 0. So my vertex is at the point 3, 0, and it's going to be opening up. Now I can't draw it yet because I don't know about the intercepts. Axis of symmetry right there, but you write it as a line, x equals 3. So it goes like that, okay, around there, symmetric to that line. The y-intercept, we let x equal 0. That's going to be easy. F of 0 equals 0 squared minus 6 times 0 plus 9, which is just 9. So when x is 0, y is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's clear up there, so I know it's going like that. So I also know 1, 2, 3, 1, 2, 3 is also up at 9. Because of the axis of symmetry. So that's helpful. This is the point 69. This is the point 09. X-intercepts, we let y equal 0. So I set this equal to 0. X squared minus 6x plus 9 equals 0. And what I want to know is that factorable? Are there factors of positive 9 that add up to negative 6? Yes, there are. X minus 3, x minus 3. Set them each equal to 0 and solve, and I get x equals 3. So I already knew that that was an intercept right there. That's the only time it touches the x-axis. Where is it increasing? It's increasing right there. Where does the x start increasing? It starts increasing at 3. It goes to infinity. Where is it decreasing? Decreases right there. Think about the x's. As it goes up, it's going left. And so it starts decreasing at negative infinity. It stops decreasing at 3. The domain, again, I have no restriction. I'm going to move this down here. So the domain is negative infinity to infinity. What about the range? What's the lowest my graph goes? It's at 0, isn't it? And it includes 0 and goes to infinity. So that is a graph analysis of a Form 2 graph. All right, looking at the back, this is a different kind of problem. It says determine the function whose vertex is 1, -5, and whose y-intercept is -3. The graph of the parabola is shown here. So now we're doing the opposite. We already have the information. The vertex is at 1, -5, and the y-intercept is, I think part of this came off. It should be 0, -3. All right, so here's what we know. Vertex is at 1, -5. So what does that mean? It means the h is 1 and the k is -5. So here's what I know so far. If f of x equals a times x minus h squared plus k, I can fill in the h and the k. So f of x equals, I don't know the a, x minus 1 squared, and the k is a -5. But what else do I know? I know that f of 0 is 3, or -3, excuse me. Right there, my y-intercept. I know that f of 0 equals 3, and that is key. So I can say, if f of x equals this, that's the same thing as saying y equals a times x minus 1 squared minus 5. Don't I have an x and a y I could fill in with that point, 0, -3? I sure do. So I'm going to say -3 equals a times x is 0 minus 1 squared minus 5, and I'm going to solve for a. So -3 equals a, -1 squared is just 1, minus 5, or -3 equals a minus 5. I add a 5 to both sides, and I get a equals 2. So what does that tell me? It tells me I can now fill in all the parts of my equation. F of x equals, I'm using this, but I now solved for the a. 2 times x minus 1 squared minus 5. And I found my equation by using the information that I was given. You're going to see a summary here for graphing a quadratic function. If it's Form 1, you do these two things. If necessary, we didn't do any with complete the square, so you sort of don't need to use that. You can just graph the function in stages using transformations. I didn't want to get into that. And in Form 2, we can determine whether it opens up or down. We can determine the vertex, etc., etc. So remember, there are two equations that show us a quadratic function. This is Form 2, the one you're used to, and Form 1, this is the one that uses transformations that we have done before, and we can graph them both in different methods.